Hello, welcome. This is Team Gliese 514B. I am Ruben. My team includes Dennis, Justin, Manuel, and Javier. We have all worked hard to keep this project truly moving forward. Let us begin by talking about an unmanned hybrid vehicle, UHV. UHV borrows fundamental concepts from unmanned aerial vehicles and unmanned ground vehicles, basically meaning that it can fly and it could also traverse the ground. Within the context of the project, many materials, hardware, sensors, and software had to be considered. Materials include generic 3D printing materials, acrylic for the metal, or carbon nanofiber for the project's overall design. As for hardware, different batteries, different motors, and different microcontrollers had to be deliberated between. Sensor-wise, there are a lot of different sensors in use, and some that had to be swapped out. Some include the LiDAR, the Pixhawk 4's internal sensors, and the accelerometer and gyroscope. Sensor-wise, there are a lot of sensors in use. Some include the LiDAR, the Pixhawk 4's internal sensors such as the accelerometer and the gyroscope, and the Pixhawk 4's connected sensors such as the GPS, radio receiver, and more. Software-wise, different software for automation had to be decided upon as well. Different tests were conducted to essentially consider the finalized material, hardware, sensors, and software. On the screen, you should be able to see some tests that are outlined in tables. For example, in the case of what material we should choose, right? Carbon nanofiber was chosen because it was resilient and lightweight. Long-lasting batteries were chosen alongside the original motors for the project, since both allowed the system to create enough lift while consuming little power compared to the other motors and batteries combinations that we were considering as a team. Lastly, the Pixhawk, as alluded to in the last part, was chosen over the Navio 2 since it was very easy to work on and had more support and functionality. Lastly, autopilot ground control software was used to ease automated missions, and also alongside ROS, it created a easy way to access data and produce mapping as well. And as such, these maps will basically be able to be used in machine learning models in the future. ROS Mavros is currently bridging both the autopilot software and the ROS operating system. Future and soon to come functionality include flight and ground control via ROS Mavros Python scripts, camera functionality, computer vision, and automated control via machine learning. Current and future functionality is still in the works, making the unmanned hybrid vehicle a robust and exciting project. To the Artemis mission, this makes mapping the moon and accomplishing tasks easier for the astronauts who will be exploring the moon and accomplishing the Artemis mission as a whole.